false, false. Then P tends to Q, that is capital P is, this is true, this one is false, this is true, this is true. Then capital P and small q, conjunction of these two. This is true, this is false, this is true, and this is false. Then this one tends to small p. So this is true, this is true, true, false. That means this one is false and this is true. Here in the last column, this position is false. That means all the entry in the last column is not true. So this is not a tautology. Here all the entries in the last column is not true. So this is not a tautology. That means the argument capital P and Q, this will small p, implies small p is not valid. Okay. Next we have to know that what is predicate. Predicate means in a sentence the word or the set of words which describes the nature or properties of a subject is called predicate. That means, for example, if we write x greater than 8, okay, this is a sentence and here x describes the set of words where it is greater than 8. That means x is a subject and greater than 8 is a predicate. Okay, so we can use the notation, that is px for this statement x greater than 8. So px is known as propositional function of the variable x. Okay, so for any particular value of x, px becomes a proposition. Okay, that means if we write here x equals to 3.8, so p of 3.8 is the proposition, as 3.8 is greater than 8, which is false. Okay, the truth value of this position is f. Now, what is domain or domain of this propositional function? The set of all possible values that may be substituted in place of the variables of a proposition function is called domain of the proposition function. Okay, so for example, this proposition Px x greater than 8, we assumes the value of the set, say capital A is equals to 1, 2, 9, 10. Then A becomes the domains, here P of 1 and P of 2 are false, while P of 9 and P of 10 are true. Okay, so that means A is a domain here. Next we have to know that what is quantification. Quantification of proposition. Quantification is another way of creating proposition. Quantification is another way of creating a proposition from the propositional function. There are two types of two types of quantifications. One is universal quantification, and another is extensial quantification. What is universal quantification? Universal quantification of the propositional function is the proposition where Px is true for all values of x in the domain. Okay, so this is the quantification is denoted by for all x Px. Okay, this symbol for all is called universal quantifier. Okay, and in extensial quantification, the propositional function Px is the proposition that there exists a value of x in the domain for which Px is true. Okay, and this is the quantification which is denoted by there exists x Px. Here there exists is called the extensial quantifier. For example, say x plus 4 less than 15. For this proposition, say it is a Px, it is let Px, then in here the universal quantification of this proposition is for all x which is belongs to 1, 3, 5, 7, 9, 11, 13 and 15. Here the domain of the set is this. Obviously the proposition for all x Px is the false value, because the value 13 in the domain does not satisfy the relation here, which is the value 13 is does not satisfy this relation, because 13 plus 4 is does not less than 15. Okay, that means this is a false. Okay, this quantification is false. And similarly for extensial quantification, In this example, extensional quantification, the domain is in extensional quantification, that means there exists x, px for the expression x plus 4 less than 15. The domain is the set of values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, obviously that this proposition is true. But it would be false if the domain is taken as the set 12, 13, 14, 15 or something else. Okay, that means this is false and this one is true.